So the problem now is find a one form. So this will be another video solving another problem. Find a one form phi such that the total derivative of d phi will be y dz wedge dx minus x dy wedge dz. Okay, so we have to find a one form phi, and if we take the derivative, the total derivative, the exterior derivative of that phi, we will get this. So which one form taking derivative we get this? That's the question. So I would say that we have to find a phi, right? Where, well, we have to say a dx plus b dy plus c dz, right? Because we have three coordinates, right? X, y, and z. We have three coordinates, and we have one forms, right? So this one form will be a linear combination of fundamental one forms. Okay. Okay, and obviously A, B, and C will be functions of X, Y, and Z. Okay, so if you guys are not very familiar with taking this sort of derivative, I will make other videos with basic calculus, and please check the previous video where more or less I give an idea of this. Okay, so we are going to take the total derivative of this. So this will be a. I'm going to erase all this now. So okay, total derivative. So this will be, so we have a and dx here, right? So we have to do d dy of a dy plus we are going to take the derivative of a to z dz, right? Why we are not going to take dx? Because d of dx is 0. Okay, it's a well-known fact from the derivative. Okay, I will do some videos on this, on basic calculus, to take this sort of things. Okay, so we have to do the same for b now, right? So db dx, right? Because this one will be y, right? Plus db dz, right? Oh, I'm sorry. So I'm not writing this correctly. I'm sorry. I'm writing it as I think. But so this will be dx plus db dz dz, right? Wedge dy. Okay. Okay, so that will be this one. Okay. So plus we have now this one, right? So dc dx dx plus dc dy dy wedge dz, right? Wedge dz. Okay, so we have to do all this now. So this one will be, so this is equal this one, dA dy dy wedge dx right? This one here, plus, now this one, dA dz wedge dx, plus dB dx wedge dy, plus dB dz dz wedge dy, right? I think this is correct, right? Okay, plus last one, dc, right? dc dx wedge dz, plus dc dy wedge dc. Done. Okay. Now we have a couple of things that we can put together, right? dx wedge dy here, and we have also a dx dy, but since this is in the other direction, we will put here a minus. Okay, so the first one will be dB dx from here. This one, do not forget that dy wedge dx is the same as minus dx wedge dy. This is a very important property of the derivative. Okay. Well, I will show this in another video. Okay. I think I said the derivative. This is the dual, but that doesn't matter now. Words are not important now. So dB dx, this one dx wedge dy, this one we have to change sign, right? So that will be dA dy, but this one changed sign, so we have dx wedge dy, and now we can get them together, right? dc dx dA dz, right? That's dx wedge dz. Same thing, we just change some sign here. Okay, let me see if I'm not lost. Plus, no, plus, yes, perfect. Okay, I think this will be dc dy minus dB dz. I took a quick note here, dy wedge dz. Let me check this one. So this dc dy comes from here, right? That's okay. And the other one comes from here, right? Right. Well, this is correct. Okay, and this one I have to change sign here. Okay, that's correct. Okay. So before we forget what we are doing, we were asked to find a one-form phi such that the total derivative or the exterior derivative d phi is y dz wedge dx minus x dy wedge dz. So we built it a form, a one form, a general one form phi, and we are taking the total derivative. Okay, let me rewrite what we have to show. We have to go for this one. So all this will be this, right? Okay, so dy wedge dx or dz wedge dx, that will be this one, right? But we have in a different order. Okay? Okay. So this one has to be equal to y, but since here we have it in a different order, this has to be equal to minus y, right? What about dx wedge? What about dx wedge dy? We don't have any dx wedge dy. So this one has to be 0, right? And what about dy wedge dz? dy wedge dz, so this one, it has to be equal to minus x Okay, so now it's only a question of writing this. Okay, I'm going to do that now. So dB dx minus dA dy, it has to be 0, right? dc dx, this one, minus dA dz, it has to be minus y. And dc dy minus dB dz, it has to be minus x. And now we have to solve this system. Okay? Now, these are simple calculations, and for some people really hard calculations, but I'm not going to get into minor calculations here, so this one is to be equal to d dA dy, right, because of this, and then you replace this one on the other, you see, and you can get there quickly. So we are going to get A equals to yz, B is xz, and C will be obviously 0. Okay, so our answer will be phi has to be yz dx plus xz dy. Okay, so this will be the final answer. Now, if you want to check, you simply pick this, take the derivative, the total derivative, and see if you get what we were asked right at the beginning. See if you get y dz wedge dx minus x dy wedge dz. Just check that, right? You see here, if you take the derivative to z, you will get 1 dz, so that will be y dz wedge dx, right? And this is really easy to check. Okay.